Hi everyone and welcome back to my channel. So before today's video, we will talk about a scenario about the main engines. So imagine that you'd like to know the actual power delivering to the propeller by the engine, or not the power delivered to the propeller, I mean just the power delivered by the engine itself, okay? So how do you know that? Or in which way you will get the number you need? So there are actually several ways to do this. The first way is like this. You use this equation here. You know this original revolution speed and the original power from the sea trail document. Also, you know this factor by the propeller manufacturer. So by the cubed law of the power propeller is absorbing, you will know the roughly how much power is delivered by the engine. So another way used by the engine builder in their factories is like this. You know this equation and you will be able to calculate the power. Remember that the revolution speed here is in revolution per minute and the torque is in Newton meters. And the power here is in kilowatts. The third way you do this is that just a very rough estimate by the fuel consumption rate and the specific heating value, and it should be the low heat value of the fuel you are using. Okay, because the water won't be condensed in the cylinder, so the heat which the water will release during the condensation process won't be released in the engine, so you will need the low heating value of the fuel. That's why. So a more modern way of getting the power of the engine during its operation is by using these equations. It's a very easy equation, as you can see here. So let me introduce you that this is the mean effective power. This is the indicating power, mean indicating power. This is the mechanical efficiency of the engine. Okay, so this number here, you can get it from the manufacturer or the engine builder for a specific engine. So what is the difference between these two numbers? From this equation, you can clearly see that the difference between this number and this number. The first is that you will notice the indicating power is larger than this because this number is less than 1, right? It's a positive number but less than 1. Okay, so the difference between those two are dissipated on the mechanical loss. You remember that into the heat. Okay, so this is the cause of the difference between those two numbers. And when you get this number here, you will be able to calculate the power delivering by the engine. Remember that this is the pressure and this is the power. So I just added like kilowatt and the pressure here for you to see it more clearly. So this number is a constant. You can get it from the engine manual. Normally the operation manual of the engine. This is the actual engine speed you are running now. This is what we get from this equation here. You should notice that there are actually two K2 constant in the operation manual. One is for calculating the power delivered by the engine in kilowatts, and another is for the brake horsepower. Okay, so you will know that the differences between those two are actually the ratio between kilowatt and the horsepower. This is not hard, right? So this leads to us to a question that how we can get this number here, because this is the only unknown number except for this one. This is easy to get. You can read it from the revolution meter in the central control room or the engine standby control. But how you get this one? Okay, that's the main topic of today. So you look at this box here. This is really nice compared to those two peak pressure meters I got. Those are shown in two of my previous videos. You can, if you are interested in, you can take a look at those. By the way, this one is made in World War II, during World War II, because I'm sure that this type of pre-max peak pressure indicator is just used for the Fairbanks Morse opposite piston marine submarine main engines in the US submarines. Okay, you can take a look into it. And now, what I'm very surprised is that if you look at the year actually here, this shows the year this instrument was built. It says this is some kind of a Japanese year. It's 15 and November. And actually I have looked up for this thing in my computer, and it should be this one. And okay, let me find the 15th. It's actually 1940. So this one was also made in World War II. And what is actually surprising is that this one is made by the US Army, or made for the US Army during the World War II, and this is made for the Army. Okay, this is just thing, you know. So it also has a lock here. Turn it clockwise, unlock it. Okay, nice. So what here inside, here it should be some kind of a parts list, and here we have all the parts. It seems that this one was never used. You look at the cord they provide here. I can tie it as this if they ever like cord. So there's nothing. If you notice, there is a missing spring. Actually, okay, I will tell you about those in detail in the following. So the spring, I have already mounted it here, so nothing is lost here. Expect something here. I know. This one should be a spare part piston rod. How it is lost. Unlucky, but we already have a non-used piston rod inside, so it should be fine. Anyway, let me this precise equipment. Okay, this thing weighs like 3 kilograms. Nice. So the base for this thing. Previously, this special thing doesn't look like a part, and it's screwed into the wooden box tail. Insert the base. Then insert the base into it. You have a temporary stand for this thing, which change the indicate paper, the graphene paper. Cylinder, but the cylindrical shaped thing which you can just wrap paper onto it. So let me introduce you to how this thing will function. Okay, sorry, recently actually I some camera is not quite clear. Has it? Anyway, let's take a look. So what you are seeing here is actually a small pencil. It can be adjusted or out. Actually, there is a very tiny piece of pencil. So imagine that if this thing and the pressure acting onto the inner piston will this mechanism upward. This lever mechanism here will magnify the small movement of the spring, the upper part of the spring. This is a connection here inserted into this thing. So the movement of this top or the whole rod here will be magnified into this one here. Also, you should notice this is not a simple lever, because you can imagine if you have a centered piston rod here, have one connection here, this lever won't be upward or downward because this point will draw an arc, right? So this is very simple lever. Okay, this is which allows you actually action the cord. So the way you need to have a cord is that take a close look at here. This upper cylinder part can be disassembled so that the cord inside and make a just connection in a screw inside. If you pull the wire here, you need to wrap the wire previously here onto this thing here, and if you pull it, this thing will be rotating, right? So this you to change the direction of the force you're pulling. Okay, so if we make some from the pulley to the I will say that, but actually not. But considering if you connect this pulley or this cord to the maybe it was just the piston rod. Okay, so you will have the downward movement by the piston transferred in the rotation in this cylinder, and you have the pressure measured by this mechanism into the movement of this pencil. What you will know is that you will get a mechanical oscilloscope here. Okay, this did by another friend. It's not my word. He says this thing really looks like a mechanical oscilloscope. Big fan in electronics, and I have this interesting word here. If you consider that you have drawn several diagrams for you to see. So these two are the standard indicating diagrams. The differences between those two are actually the movement of this cylinder, the movement of this pencil here are 90 phase between these two diagrams. Okay, so you can actually imagine if I fold this one and just to here, or swap this part to here, you can actually get a closed loop diagram like this. Okay, so actually from the thermal power delivered by the engine is actually in between those two lines, or the closed surface area formed by the graph here. This is actually actual work. If this is the pressure, this is the sweep volume the piston has covered. So if you know the actual power and you know the movement of the piston, okay, from here, this is the end of the not the end of the escape engine, but if you know the distance here, the length, okay, then indicating pressure here. Okay, the indicating because this is actual power. You can measure with a meter, pressure meter, or this one. So formed shape diagram here. This is used for like tuning the engine. So you can notice that these 5 shorter lines are actually the compression peak pressure. Imagine that if I don't connect this cord to any of the activating mechanism, if I just leave it, and this one will just right move upward and downward during the engine, then it will make a straight line, right? If you just to save the paper used, you can just slightly change this position and make a new line. Change it during tuning of the engine, like the how can I say it? Usually they will increase the distance from the not the connecting, like the piston rod bottom base to the crosshead pin, in a slightly increasing distance of the sheet. Yeah, in between the top of the crank head pin, top of this pin, and the base of the rod base, they will add some to adjust the actual volume between the center of the piston and the cylinder head volume here, some kind of change the volume. And also you will change the volume of the of the cylinder when the piston is at the top lower bottom or the bottom dead center, but actually the ratio, the compression ratio is changed in this way. Okay, so what is this long lines mean? Actually, you know, this is a maximum pressure combustion, just like using a peak pressure meter. More than like you have a pressure meter here, pressure meter, and there's some kind of here, and you connect it to, so that whenever the pressure is higher than in the bottom pipe in the piston in the pressure meter, will be open and the pressure will gradually increase here, and finally you will get the peak pressure happening in the chamber. Alright, so this is doing this using a mechanical way, just the peak pressure. Now you understand that this is usually tuning the firing pressure or the fuel pump, like the fuel index, or the, how can I say it, injection timing. Okay, so these two are the normal diagram graphs, and if you happen to have of shape in this part of the diagram, it means that you have a clogged injector or the clogged fuel valve. You have like some kind of a vibration in pressure here. So you have I mean, this line is actually the normal condition of the engine. So considering the first situation here, what is happening here is that you have a higher how can I say it, ignition pressure. Okay, you have a higher than normal ignition pressure. So this actually means injection is too early. But why you don't have like this? If the early angle is too high, you will actually have a separation of the line here. If you don't have such kind of separation, this means it has slightly too small injection timing. I mean, too large injection timing, but not, it develops into a separation. So for the second one here is that a leaking high pressure fuel system, whenever in the fuel pump or in the fuel valve or the injector, because you have a compression process, but you have a abnormal power stroke that the fuel emission usual. If sometimes you have both of the compressor line lower than the usual, this means actually you will have a leaking combustion chamber, like the piston ring, the piston head. Sometimes there will, in that condition, you will notice a significant amount of oil mist in the crank, like the scavenging space. Okay, so in the exhaust valve, I mean, if you have a combustion chamber leaking, this is about some special kinds of rims. And let's talk about what we are getting inside this box. Okay, so maybe just let me try to. Okay, this is too precise to me that I need to take care of it. So it might need some. Sorry for that already. Okay, let me put it in a stable place. Really nice. So this is cord. I don't think I need to. This is the spare part spring. This spring here is to drive this recording mechanism back to the position. You see there is a spring, right? So this is the indicate paper. Actually, I think I can even cut from some normal papers to save this thing, because you know it has already 84 years old now. I don't really want to waste it unless I have some space to use it, which I will talk about it in a few minutes. These are 6 springs. These 6 springs are in groups. So if we take out one, it marks as piston 9.06 diagram, 0.6 millimeter and 54 kilogram. This number means here piston here means you have a 9.06 millimeter diagram piston used when you're of a piston here. Then this specific spring, when used with that piston, you will 0.1 megapascal pressure. You will get a 0 meter in the diagram, not the actual like the deformation of this spring. You remember, this doesn't mean like if you add, or like if you like put 10 Newton force on this spring, then this spring will extend for 0.6 millimeter. It doesn't mean like that. It means if you have a 1 kilo on the, how can I say, on the piston acting on that diagram, you will get 0.6 millimeter in this graph. Okay, it's simple, so you can see that I remember this should be 0.5. Okay, 0.5 millimeter per kilo and 60 kilograms. Same, because the own dimension of the piston and the piston cylinder here. Sorry, it should be English here. And it has a spare parts piston and liner. You can see there is a piston, right? This piston isn't like to be a normal shaped piston. It's just kind of inside, because there will be a screw covering this one. In this one to the piston rod. So this is the piston piston and sorry. So what is this tool here? What is this one? Okay, if you look at this, you will notice it's actually the matched shape. This is for like dismantling and remount the. Okay, and this one here, I don't. What is this one used for now? I don't understand this up to now, but maybe later. Okay, so this one here, I don't understand what is this one. It is, sorry for the focus. It's hard to focus now. Okay, it has some kind of a spiral shape at the end and kind of a, I don't understand it. Yeah. This, oh, sorry, this is just a wrench. This is just a big wrench. Okay, here is just special kind of wrench. Another special kind of wrench. Oh, this thing here. You know what? I find that all of the indicators kind of connecting this, and they ask you to use this special kind of wrench to it or dismount it. Okay. By the way, all this here we have a wrench. This thing here we have wrench here. Okay, so okay, and this is like the cleaning rod for the piston liner. What is inside this little box? Oh, there are actually some spare parts pencils. You remember there is a small pencil here. There are another 3 spare parts and some small nuts. I won't just pour it. It's too small and nothing too interesting happening here. Okay. And okay, so only 2 things. Oh, 3 things. Sorry, this is a hook. This cord here to this hook, and will be connected to some part of the engine. Here that I said some kind of need to have some kind of piston rod here, right? This isn't done by connecting directly to the piston rod because the movement of too long, like several meters. The engine builders do there is actually they made a cam and a cam follower. This cam is a certain with the actual engine timing system and profile just models the movement of the piston rod. So this hook is connected to the follower, usually next to the injection. Okay, so only 2 things we haven't talked about are this and this special valve here. Okay, so we have 6 springs divided into 2 parts. Actually, just 0.5, 0.6, 0.5, 0.6, just another 2 spare parts. So there are 3. These rulers are the same. They are in like 0.5 millimeter, 1 kilogram. This is used for measuring the pressure shown when you are using the 0.5 millimeter, 1 kilogram piston, like this one. You are using this ruler, sorry, to measure the height here, like this. I mean, if you have, I forget to say, before the measurement or the measurement of the pressure, you need to take an atmospheric pressure line, which disconnecting this one, and you pull here, this cord here, and so this will make a straight line, and you measure the height like this. If, for example, if I just like this, and you will get like maybe 77 or 76 kilogram maximum power. I believe there is a 0.6 ruler here, and just another 2 pairs. Okay, so another thing here is this mysterious verb. Mysterious, really. Look at how precise they made such things in 1940s. Okay, this one here, 90 kilogram per centimeter. So what actually line, this one is used when the actual power, or the, how can I say it, the ignition power is over 60 kilogram per square centimeter. When connected, you will connect this to the engine indicator cork first, this one to here, then the engine indicating, open this one here. You will this is just kind of another indicating cork, but I don't understand or really understand. And actually, the pressure releasing hole here, you can see this one here. So when now it's in the open like this, and it's a ball valve, and if you close it, this this upper part, which is connected to here, will be connected to the release hole here, which pre-release the pressure inside the measurement chamber. If after that measurement, I understand why. Because in some old engines they don't have this hole in their indicating cork, and if disconnect this directly, this one will be shut off the engine and like to be propelled at a very high speed. Okay, so few reason. This connector and this connector are different here. Might be another reason, like an adapter to some Japanese engines or something, because all the engines are in this kind of a connecting, just this kind of a connecting in such modern engines. So what I will do is that I might take this thing to the museum in like April or May next year, because they will open and they will have exhibition there. Like you can search no engine, natural gas pumping station, and horsepower, connecting rod, the indicate cork connection. I might take this one to there and the indicate diagram using this 84 years old instrument to another like some kind of a years old engine. So video, and hope you